So let me say what I should have said about that. Anybody familiar with my writings certainly isn't going to think of P.E. Meehl as an anti-statistical type psychologist. When my undergraduate minor was in biometry, 15 credits of biostatistics, and from an excellent teacher named Treloar in the School of Public Health. And as a senior, I took a year course in mathematical theory of statistics in the math department, which I count as one of the 2 or 3 best courses I ever had at the university. And then as a graduate student, as we all did in those days, I took a year of statistics in psychology and education in EdSite from Paul Meehl Johnson, who was trained by Fisher and Eglin Pearson and company. Went to England to study. And I took factor analysis, and post-PhD I took a course in mathematical theory of probability in the math department, and in matrix algebra in the math department. So for heaven's sake, don't think of me as either A, an ignoramus, or B, a guy who hates statisticians. And I said some of my best friends are statisticians. In this course, in past years, I have had 4 statisticians give lectures. Ray Collier would still be in here for 4 sessions if he hadn't retired early. Was from EdSite. And James Bowen, a professor of biometry in the medical sciences, he'd still be lecturing in here if he hadn't decided to become an assistant dean and didn't have time for that. I've had Barry, who was head of the school of the division in our School of Statistics of Theoretical Statistics. I've had Seymour Geiser, who was head of our School of Statistics, in here lecturing. So nobody would do that if he had some hang-up against statisticians as a genus. What I should have said is there's a subgroup of statisticians who have a certain arrogance toward the social or medical scientist, and they get that, I still think, in an easily understood way. If you are in the role of telling people how it is, which means being a statistician, talking to some poor researcher, or being a college professor, or a priest, at least before the church went down the tube, or a physician, take 2, call me, or a certified public accountant. If you're in any of those rackets where you make your living telling people how it is, there is a certain tendency to develop habits of intellectual arrogance. The statistician, it seems to me, is very subject to it because of the big disparity between what he knows and what his pitiful little clientele usually knows. So they get in the habit of assuming that if you're not a PhD in math stat, you don't know what a t-test is. Certainly you wouldn't know what a derivative is. And that means that when they run into psychologists who are more, and economists who are more mathematically knowledgeable, they don't seem to think that we possibly could be. And my experience here is not confined to cases where I personally have been put down. I'm really thinking more of colleagues and students of mine where I have read the referee's review of a paper, and it was perfectly apparent that this was a statistician who didn't bother to read what this poor dumb psychologist wrote, didn't bother to find out what the writer was trying to get at, and simply subsumed it under some standard heading, and oh, this is Bayesian, or this is blah, 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 and the hell with it. And they do, there's a certain group of them that have a tendency to do that. I could name 2 or 3. I won't. But there's one statistician that every psychologist and sociologist knows by name. For God's sake, I hope the editor doesn't send it to him, because if he does, it will be rejected. It's just predictable. This guy will reject anything about statistics that's written by a psychologist or a sociologist. He's famous for that. Okay, that's the way I should have said it. I love statisticians, and I like statistics. Now, last time we were talking about the crud factor, and I want to give a single numerical example, or a couple of numerical examples, and I don't want to take class time. We're really running behind. We always do in this class. I can't seem to control my manic free associations. There's a document which gives 6 or 7 numerical examples for you to pore over at leisure. But I didn't have a supply of them, and my secretary was pressed. I will pass it out next time. So today I'm just going to give a couple of examples and talk some about how the crud factor is not of negligible size. Let's take the case in which we have a theory which is literally true, for starters. So we have T, and in our epistemic equation, so to speak, we have some auxiliaries. Now, suppose there are only 2. Now, that's very optimistic, isn't it? There's, let's say, an input auxiliary, like in my TAT thing, and we're going to tell people you flunked the mid-quarter, and that's supposed to make them anxious. And if that's false, then the theory is, then the experiment is not satisfactory. And then we had an output auxiliary, which was the theory that the TAT is a good, adequate measure of need affiliation. So you have an input and an output auxiliary, and then you have the ceteris paribus clause, and then you have the specific conditions, and then you have the instrumental auxiliary. And that entails that if you observe O1, you will observe O2. And to make life easy for us, I'm going to assume that this one is not problematic, either that there isn't any instrument that doesn't belong to psychology, no GSRs or whatever, or that it's perfect. And I'm going to assume that you can be 90% confident that the experimenter did what he said and that they didn't leave out mentioning anything that he did, more important. And I'm going to assume that the ceteris paribus clause has a probability of 0.9. You may think this is a little low. All right, if you insist on raising this to 0.95, I'll knock this down to 0.85 and make it out about the same. These are not exact values. These are ballpark figures that I've chosen that are not goofy, in my opinion. And suppose there's a 90% probability attachable to both of the auxiliaries, both the input fellow and the output fellow. So what's the joint probability, if we will assume independence here, that the conditions for this equation to go through are met? So it's 90 to the 4th, which is 0.66. I'm asking what's the probability that the stuff on the left holds, and we're assuming that the theory is literally true. But these are considered problematic. I'm assuming there's no instruments. And the question is, what's the probability that the stuff on the left works so that O1 horseshoe O2 is implied in the eyes of omniscient Jones? And it turns out to be 66. So that if you had perfect power, suppose you followed Cohen's advice with a vengeance and you had got 5,000 cases, so the power function is 0.99 for a value that you're interested in, then that, putting this in terms of probability terms, and I don't want to hassle the question of how you apply probabilities to specific cases. We'll do that later. We can't do everything at once. That means that your chances, so to speak, of getting this result, at least as a consequence of the thing on the left, you could get it by dumb luck about the crud factor, but the chances of you getting that result because of the theory being true is only about 2 out of 3, even if you had perfect power. If you took Cohen's advice and assigned a power function of 80, then what we get is a net probability only a little better than even. In other words, the parameter value goes through all right because the stuff on the left, if it were met, that the chances of that being true is about 2 out of 3, but the chances that you are able to show the effect, say at level alpha equals 0.5, is 0.80, You've got that on your pilot experiment, and so the result is that 52 is, you have about an even chance of the result flowing from the theory. That's not too encouraging, is it, brethren? That's not too encouraging. That means that a very good theory, a perfect theory, a theory that's got 100% verisimilitude in the eyes of O.J., only has, with 80% power, a little better than even chance of panning out. Now suppose you have a false theory. Well, it's a theory that has not, it's totally false. It doesn't even talk about the right kind of entities, let alone having the right mathematical functions and connections between them. It's just a totally false theory, like the brownies curdle in milk or something. Well, how does that look? Suppose that we had a crud factor of 0.30. And we're going to do a t-test rather than a correlation coefficient here. We're going to divide our independent variable at the middle, that's x, as in our earlier example of introverts and extroverts. We're going to divide the independent variable at the middle. We're not going to throw any cases away, so we're not studying the top and bottom 14% or 27%. All the cases are in. Well, what's the average value of the introverts? These are what's the mean value on our variable x? Anybody know what that is? Well, see, they don't teach beginning stat the way they used to. The mean value of the people in the upper half of the normal distribution is approximately 0.8 in standard deviation units, because that's the mean deviation. Normal curve mean deviation is 0.8 of the standard deviation. And of course the mean value of the people who are above the mean is that's a fold-over proposition, so the average value of the people who are in the upper half is at 1 mean deviation, at 0.8. And the extroverts, the folks who are below the mean of our variable x, our input variable, is correspondingly minus 0.8 in z-score units. So the difference on x is plus 1.6 in standard units. That is, our introverts are 1 6/10 standard score units above our extroverts, the mean of our extroverts. Now, what's going to be the output variable y difference? Well, you remember that if one writes the regression line of y on x in z-score terms, the tangent of the angle theta in there is the Pearson R. I'm assuming everything's normal and linear here. The slope of this thing is R. The expected value of people who are so many units above the mean on x is R times how many units they are above the mean in x. And similarly, this has to be knocked down by a factor of 0.3. So what you have is 1.6 standard score difference between the introverts and the extroverts on the, quote, input variable. And we are now going to multiply that by the crud factor correlation coefficient to predict the average expected difference on our output variable, our TAT affiliation or whatever it is, which is 0.48, or approximately a half standard deviation. Now that's something worth dwelling on, is it not? We picked our theory out of the right-hand hat, and we picked a couple of variables out of the left-hand hat, and the crud factor in the left-hand hat is 0.3. And so we got a TAT affiliation thing and an introversion thing. Who knows, you know, why? It came out of that pot. And we already have then a half a sigma expected value on the output variable. Yes?
I think it might be worth throwing out that that's Cohen's definition of a medium-sized effect. It's half a standard deviation.
Is that what he calls it? Yeah. All right. Thank you. I had forgotten that. Okay, that's a medium-sized effect. Well, what'll that do to us? I don't know the average sample size in the soft areas. What I did roughly is this. I grabbed 3 or 4 journals, recent issues, Journal of Abnormal, Journal of Personality and Social, the Journal of Clinical, another one, and leafed through and tallied all the N's that varied from an N of 13, I forget what they were studying, to an N of 1200. But of course it's extremely skewed. But a median value there I got was around 37 for the 2 groups. That's about what you'd expect. Typical study we do in clinical or social or whatever has 30 to 50 people in the one group and 30 to 50 people in the other group. Well, if you assume N1 equals N2, sigma 1 is sigma 2, to make life easy, the standard error of a mean difference in the usual T formula is approximately 24 in standard score units. So that means that the expected T is 48 over 24, or 2, T of 2. Now, one-tailed critical T, and in most cases it is rational to use a one-tailed test. There's very few theories. There are a lot of soft theories, but there are very few that are so flabby that all they say is the X's are different from the Y's, but I have no idea which direction. There could be such a thing. Almost never, even in soft psychology. The one-tailed t-test to give you alpha 05 is a t equals 1.65. So your expected t is out about 0.35 from the critical t. And if you look that up in t tables or with this number of degrees of freedom, you just well use the normal curve tables. You'll find that the power is about 32. So we have a crud factor odds, or not odds, a crud factor based probability of confirming our theory about 1 chance in 3, 32, compared with our Simon pure true theory where our expected is 52. So at least there is a difference between them, but not much to write home about, would you say? What I've done in the material I'll pass out next time is to ring the changes on these parameters, considering favorable cases and unfavorable cases, using this number of degrees of freedom throughout. And of course I have completely omitted the matter of what surfaces in the research literature. I've simply referred to the probability of getting the predicted observational result. I have acted as if people are just as likely to send in a non-significant experiment as a significant one, which is quite clearly false, although we don't know the size of that. And we also have now some quantitative data by a counseling psychologist, Armstrong, is it? A couple of years ago, on editorial and referee policy, which everybody knew existed, but it was only recently that I came across that paper. And they sent faked up papers describing the same kind of experimental design, the same variables and everything, but in one case with significance and the other case not. And it was quite clear that there was a pronounced bias on the part of referees and editors to accept the papers that gave statistical significance and to not accept those that didn't. And as I said before, that's not wholly irrational because of Fisher's point about you can't prove H null. With moderate n, you have shown something when you refute H null. With moderate n, and hence moderate or low power, you have not shown much of anything when you fail to refute it. So this is not, when I speak of a bias, I don't mean something spiteful or unfair. I just mean a slant. That is, the net result is a rather, I think the ratio is something like 3 to 1 in the Armstrong study. Now, students in the past, when Licken and I harp on this crud factor, have sometimes said, well, all right, there's a crud factor, and we should worry some about it. But they say, due to the imperfect power, we don't have to worry too much about it because it's going to be hard, despite the crud factor, to get to alpha. And so that means that things are not as bad as Meehl and Licken make it appear. And that's not a dumb argument, but it's wrong. And the reason it's wrong is that the task, when we perform a significance test to study a substantive theory, is to separate the sheep from the goats, is to distinguish the good theories from the punk theories. And no procedure that's supposed to tell two things apart is ever improved by fuzzing up your criterion. I mean, that would really be getting something for nothing. It can't make things better in telling the good theories from the poor theories to say, and not only that, we're not even sure about the parameter. See, in that diagram I passed out, we have a causal arrow running from the state of the world to the statistical state of the world, so to speak, what the statistics books refer to as the state of nature. And then we have a causal arrow running from that parameter to the sample, using causal somewhat loosely, apologies to the philosophers present. And then we have an inferential arrow in each case that goes in the opposite direction. We want to infer the parameter from the statistic, and we want to infer, given our inference as to the parameter, to the substantive causal theory. And you can't really be consoled by the thought that the power function is less than 1, and therefore you will have less confidence in a given delta being above a certain value, because that fact that makes it harder to refute H null in the cases when the theory is false and based upon crud also makes it harder to come out with the result that you want when the right-hand side follows from the true theory. You can put it very simply. You can think of it in terms of a certain probability, say, well, alpha. No, I don't want to say alpha. I can't say alpha because I got to compare alpha with 1 minus beta. Let's just call it power. Power. And that's going to be multiplied by an actual p-value in both cases, p for the true theory and p for the crud factor theory. Now what we want to do is get the difference between those two. That is, we want pp to be a good deal bigger than pc. Now, if delta p is what we are interested in making our comparison, as we carry on our research career, we're constantly trying to separate the sheep from the goats. And what we're doing when we say you have imperfect power, of course, is to say that delta p is being knocked down by some p, which is the power function. So that can't do you any good, can it? I mean, delta p is not as big as you would like. Now we'll knock it down further by multiplying it by the power. So attenuation of the power simply means that our ability to discern the difference between a true theory and a crud factor thing is going to be correspondingly attenuated. The rule there, as Neyman and Pearson would put it, is the same as Milton Friedman's economic principle, you know, the one that the knee-jerk liberals don't believe in. There ain't no such thing as a free lunch. Tanstaffel. Somebody pays. Well, type 2 and type 1 errors are always involved in a trade-off. There's no magic. You can't fiddle with statistics. You just can't do anything. No matter how clever you are with gamma functions or whatever, there's no way for you to do something with statistics that will cut down an error of the one kind without increasing the error in the other kind, unless you increase the sensitivity of the design, in the logical structure of the design, the degrees of freedom, or the reliability of the measures. Those are the three things. And if you're stuck with certain instruments and with certain degrees of freedom and a certain logical design, then changing a cutting score, like saying, well, I'll require alpha 01 because I have a phobia of the crud factor, and that means that the true theories are going to have a harder time showing themselves to be correct. There's just no way you can get out of that. The trade-off between errors type 1 and 2 is always present. Whichever formula you use, whatever type of analysis, that's a built-in feature of the process of statistical inference. So you can't console yourself that way. In a given domain, of course, it might be quite rational to lean over one direction more than the other. I'm not saying that there aren't any rational grounds for saying I'm going to make this 01 rather than 05, or 001 rather than 01 or 05. It depends on whether I'm doing quality control in industry. There's so many barrels of shotgun shells coming out, and I got to fire off so many of them if I'm an industrial quality control statistician, and I set up a certain level of defect that scares away 10,000 customers when the gun explodes and so on like that. I work all of that out. I do that in terms of the economics. And quality control in industry is one of the few places in which one can optimize the errors alpha and 1 minus beta, because he knows what he's optimizing. Bucks, see, or lost customers. But in most cases, when what we're gambling with is not shotgun shells or shooting at enemy submarines or whatever, but what we're gambling with is truth, as one philosopher wrote a whole book called Gambling with Truth. When we're gambling with truth, then we don't have a satisfactory way of assigning utilities to the two kinds of mistakes. Nobody's ever figured out a way to do that, and probably nobody ever will. You can assign differential utilities in industry, and you can assign differential utilities clinically sometimes. They may be rough, but we could say, for example, it is 10 times more serious to miss a silent brain tumor by not performing a procedure so-and-so as it is to perform it and find out that somebody doesn't have a brain tumor. So that in cases like that, we can plug in utilities. At least we can set bounds on the ratio of two utilities. As soon as we can set bounds on the ratio of two utilities, we can write inequalities involving multiplying the p's by the u's and so on like that. But in this context, testing substantive scientific theories, nobody has a clue how you would go about doing that. You know, it's like saying, well, how much worse is it to believe a false theory than it is to fail to believe a true one? I mean, 7 to 1? What will you give me? I mean, we don't even know how to get a handle on that kind of problem, you know? Some people have written strong statements about that. If you've never read William Kingdon Clifford's essay, The Ethics of Belief, that's a pretty amusing essay. And he ends up saying, with italics, it is wrong everywhere and for anyone to believe anything whatsoever upon insufficient evidence. I mean, you can't vote for president. That's probably an irrational act anyway, but I mean, you can't do that. You sure as hell can't get married or decide where to go to graduate school if you followed William Kingdon Clifford's advice. It's much too strong. And William James, who was fond of him and knew him personally, they were both, for a while, I think, at Harvard. I forget, Clifford may have been mostly an Englishman, but they met and they liked each other. But William James, who, of course, took a very different view of things and wrote books like Pragmatism and the like, and The Will to Believe, he said he felt kind of sorry for Professor Clifford because he said that Professor Clifford seems to believe that the worst fate that could possibly befall a person was to believe a false proposition. Well, that's the way Clifford's mind worked. But you can see if you started to play the industrial consultant game with gambling with truth in the sciences, you would have a heck of a time doing it. As an individual researcher, of course, you know something about your fears and hopes in this respect. I mean, some people like to go out on a limb and play at Popperian, and some people like to stick very close to the facts. And it is not irrational to introspect there and say, what kind of a mind do I have? What kind of a mind do I have? Fred Skinner, somewhere in the B of O, makes a snide remark about psychologists who are more interested in the accuracy of their guesses than they are in nature. And Skinner does not want to get stung and sticks very close to the facts, as you know. It's the closest to a pure dispositional theory of the mind that anybody's going to invent. Nobody's going to outdo BFS in that respect. He got stung badly. One concept in B of O, the reflex reserve, and there wasn't any such animal. And he's been careful ever since, so that in his later writings he doesn't even like to talk about drives, although in the Behavior of Organisms, the section explaining why you introduce drive as a state variable is one of the clearest, most powerful analyses of that problem that you'll ever read. The reflex reserve. I can tell you stories about that. Skinner really believes his own thing, unlike some psychologists. And when he was thinking about some subject and about to either do an experiment or write a paper, especially if he was going to write a paper, he wouldn't talk to you about it. If you came in and said, Professor Skinner, I've been wondering about the concept of the reserve as it relates to blah, 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 and he'd say, well, I'm sorry, I can't talk about that this week because I'm afraid of depleting my verbal reserve. And he meant it. He didn't want to spill it out on P.E. Meehl, graduate student, and then it wouldn't come out on the printed page, you see. So he believed his doctrine. What a character. Well, all right, I hope that numerical example convinces you that the crud factor is not just a little thing you say, that's just a little piddling little source of error, not something that we need to worry about. And in the examples I'll pass out next week, I consider the good cases where it would be pretty easy to tell the good theories from the bad theories, and then I take some other values of those parameters in which there's only maybe a 10% difference in the batting average. So that the box score in a bulletin article, in a domain in which there was a very large crud factor, a lot of methods covariance, let's say, if you're using personality inventories, for instance, or ratings. If you have a domain in which there's a large crud factor, but in which the substantive theory really doesn't predict big differences, predicts only, what kind of a difference did he call it?
Medium.
All right, medium difference. Suppose the theory is that kind of a theory. And yet you're working in a domain in which, due to the instruments you're using and other things, you get a very high crud factor. Under those circumstances, a box score, even if there were no selection in what gets published, would lead to quite small differences, 10 or 12% differences between the true theories and the false theories of the domain. Well, somebody should research the crud factor as I say, Licken and I did it just to see whether it was there with a huge N, and we got all these goofy chi-squares with which Lutheran synod and whether you like printing better than woodwork. But as to magnitude, now, that's obviously going to vary from one research domain to another. We don't even have to do any research to know that, right? I mean, it's going to be sizable, for instance, in the ability and achievement domain. Everything in, as Jensen says, everything in ability and achievement is positive manifold, and G percolates everything. See one of the recent issues of the, what is it called? Is it counseling psychology? Vocational behavior. Very nice issue last year, I think, with Hunter and Jensen and Bob Thorndike. G is everywhere, and it loads even low-level tasks. I mean, if it doesn't have to be learning to be a brain surgeon. It can be cleaning the latrines more efficiently. And it turns out when you have big samples in the military and industry, the so-called general intelligence factor percolates through everything, as you might expect. I mean, if you don't read the directions or don't catch on to them, you're more likely to bust the equipment and so forth. So somebody should research the average size of the crud factor in different domains, but there's not much point in doing that if they have to rely upon the published stuff. At least you would get an estimate. You could say that this is a rough ballpark figure if we're talking about social behavior, and this is what you get if you're talking about broadly the mechanical domain of abilities, and this is what you get if you're talking about psychopathology, like the MMPI scales. People do invoke correlations in the 30s and 40s as support for substantive theories, don't they, in the soft areas. That's not some horrendous rare occurrence. That's really quite common. And the more you focus on the value of T and the smallness of P, rather than upon the actual correlation, the easier it is to do that. But let me give you 3 or 4 examples that I don't know what the representative value would be in those demographic variables we mentioned last time, but I'd be willing to bet my own hard-earned money that they would be running 30 plus. That is, correlations between various measures, such as interests, attitudes, values, beliefs, IQ, achievement, information, and so forth, and things like social class, geography, and the like. Take some widely used psychometric things. The MMPI keys were developed without regard for factorial purification, or, except for PT, internal consistency. And they were built by empirical keying, that is to say, doing item analyses in this big pool of 550 miscellaneous items on a variety of subjects against formal diagnosis and comparing patients with those diagnoses with Minnesota normals. Wasn't quite as purely blindly empirical as people make out when you get to digging into the data, or had a chance to talk with Hathaway. But it was pretty much like the strong. There was a little fiddling here and there with the content, especially when some items behaved in ways that they didn't like with regard to other keys and other diagnoses. But by and large, it was 90% a pure, blind, empirical keying. So an item ends up on scale SC or PT or PD because it works, because it shows a difference between the psychopaths, diagnosed psychopaths, and the general Minnesota population. Some of these taxa, groups that are used in the item analysis, are, we usually think of descriptively and psychodynamically as being almost the opposite of others. For example, in psychoanalysis, one thinks of the obsessive-compulsive as being, in many ways, the opposite of the hysteroid. And that would mean PT versus HY. Certainly we think of the manic as being the opposite of the depressed. You think of the psychopath as being very different from the anxiety-ridden individual or from the obsessional individual. If you look at the correlations between the MMPIK scales, pairwise, they run middle to high 30s. And that's true in the pathological population, and it's true in the normal population. These are gigantic samples I'm talking about. These are stable numbers. The correlations between if you just pick an arbitrary pair of MMPI keys, there'll be 45 altogether for the clinical scales alone. You will find correlations running typically in the 30 to 40 range. I think the median is actually above 35, as I recall. Or take the strong vocational interest blank, which was also built by criterion keying against persons who were successfully functioning. That doesn't mean they were overjoyed with their work, but they were at least making their living as a CPA or a forester or whatever it was. Analyzed against men in general, but men in general doesn't really mean men in general in the strong. They made an effort to get a sample of men in general, and it turned out that when they did that, guess what? Ho, ho, ho. The lawyers and doctors and engineers and all those people are so much more alike each other than they are like the lumpen proletariat, not to mention the ordinary blue-collar worker, that the keys didn't work. So they went back to defining men in general as men belonging to one of these occupations. Well, what do you get there? There I haven't looked up a grand mean. I took a sample randomly out of the table in this book on the strong, and pairwise you're getting values in the high 30s. Harrison Goff's California Psychological Inventory. Now that was built for normals. Again, empirical keying from heterogeneous set of items. Goff was a Minnesota-trained clinical psychologist. In fact, he was my first PhD. Not bad, huh? And he did not attempt to do any kind of factorial purifying. He took what he called folk concepts, like responsible and cooperative and things like that. Item analyzed this heterogeneous pool. The average pairwise correlation in his large standardization sample of those CPI scales is 0.44. Happens to be the same for both males and females, 0.44. Or take an example where the investigator made a heroic effort on theoretical grounds to purify things. Louis Leon Thurstone, in The Primary Mental Abilities, having invented factor analysis, proceeded to factorize things. And Thurstone, when he would look at some factors, as you know, it's not obvious from his writings, but from Merrill Roth, the late Merrill Roth, who was a Thurstone PhD, he told me that Thurstone taught people to spend a lot more time reflecting on the factors and arguing and thinking and introspecting than doing the statistics. The idea was after you got a big factor that was saturating flags and numbers but not saturating something else, then you would introspect on how you did that flag thing. And why did it matter whether it was flags moving into 3 dimensions or versus like this? What would that be? And how could we change those items to reduce this undesirable saturation with this other factor? They worked very hard at that in the Chicago lab. And guess what? The primary mental abilities, of course, this is before he was doing any oblique solutions. These are all orthogonal solutions. It's before Baramax. Nobody invented Baramax. It's simple structure. You just try to maximize the number of zeros, translate damn near zeros, okay? And so you move the axes around until you get a lot of zero loadings, and that means that some other stuff now has to have big loadings. And so those underlying psychometric factors are at 90 degrees to each other. But as you surely all know, that does not tell us whether the scales christened for the factors will be orthogonal, and they never are. It's impossible to fix them so they are. Not just hard. Impossible. Well, what happened with Thurstone's primary mental abilities? The average cross-factor correlation is 0.28. And that's also the median. And the range, pairwise, cross-factor, strike that, cross-score. I shouldn't say cross-factor. These are the scores that are supposed to be relatively pure for the factors. The range goes from 0.1 to 0.56. Scales based upon an orthogonal solution of the factor problem. And then I stumbled across a paper I wrote for D.G. Patterson when I was a graduate student. I had built for my Summa thesis as an undergraduate a rating scale for college teachers, student rating scale. And so I pursued that for another year. Patterson wanted to get me to do a PhD thesis on teachers' rating scales, and that did not mobilize much libido in me. He said, D.G. Patterson was a very directive counselor, and he said, well, you mean, Paul, I'm going to turn all this stuff over to somebody else? And I said, yes, Professor Patterson, and that was that. Well, I started out with a huge list of variables which I culled from all of the then available teachers' rating scales, like Remmers and Brandenburg and other people. And I did a bunch of statistics on a preliminary group which, among other things, involved using F in a way that Fisher would call sinful, but I don't. And that is choosing things to have high F, because if you have equal degrees of freedom upstairs and downstairs, it is a measure of discrimination, even though, in fact, it's supposed to be a test of significance. And I also picked these for having good correlations singly with the global rating. My scale ended up with overall, where would you place this guy among college teachers that you've had? That's a very interesting field, by the way, despite the fact that it wouldn't hold me for a PhD, because usually the things that faculty say against student ratings are false. Like they say the only thing they rate you on is whether you make jokes. Well, the humor variable has a very weak correlation with the global rating. And the things that students rate professors on that correlate best with the global rating are exactly the ones you would hope, like how well does he explain the subject matter, how intellectually interesting is the stuff, how well does he prepare for class, and things like that. They don't give a damn whether his vest has got soup on it. They can rate it reliably, but it turns out not to be very predictive of the global rating. Well, I picked these because of their. I tried to hold down the halo effect, and at the same time get the ones that were more reliably judgeable. You get a class of 25 people. The Spearman-Brown reliability of college professors' ratings is in the 90s. In the 90s. So what happens with these? Well, the pairwise correlations between these different, this is not psychometrics now, this is ratings. Pairwise correlations go from 0, so it's not all halo, to 0.9, with a median R of 0.52. Unpublished paper, P.E. Meehl, 1942. Well, enough of that. It would be kind of fun, although it would be boring. It would be one of those botanical jobs that's boring as heck, but would be a useful contribution for somebody to really take a random sample of the literature in which you have big enough ends that you can say, I'm getting reasonably accurate estimates of the parameter here, and see what the crud factor is, and what its range is, and how it differs from one research domain to another. I'll bet you that 25 to 30 is not an unreasonable figure. I'd be willing to bet money on that. Okay. So that's number 6, the crud factor. That since in social science everything tends to correlate with everything, and not by a negligible amount when you're when you're relying on refuting H null, which says delta equals 0, has this tendency to make a theory that has negligible verisimilitude look good, because if you pick variables out of one pot and the theories out of the other pot, the crud factor in the variable pot will make it look as if the theory had some substantive truth, even if it has none. It's difficult to evaluate the problem of the direction of the algebraic sign of the crud factor. That is somewhat reassuring, and as you say, well, if I pick variables out of the pot, even if I use a one-tailed test, the question is which direction I'm going, and I should really divide the power by 2. Well, in the things I'm going to pass out, I have done that. I think that's too much. I think that the Bubba factor combined with positive manifold means that you really shouldn't be knocking down the power by a factor of 2. But if you do, you can still show that there's going to be a sizable amount of pseudo-corroboration of totally false theories, theories that have no verisimilitude whatsoever, given the two-pot model. All right, number 7. Pilot studies. Now, I find that students get confused about this one because they think I'm contradicting myself to be pushing Cohen in the first half of my list and then beefing about this in the second half. But it's not a contradiction, and it's not a criticism of Cohen's point. It refers to this trade-off problem. Why do we do a pilot study? I dare say most of you, if you're on your dissertation work, did a pilot study, or at least your advisor had done one, or somebody had done one. As far as I can make out, questioning people, students or colleagues in the faculty, why do you do pilot studies? It falls into, the reasons fall into two broad groups, two headings. I'm not counting finding bugs. That's a pilot study. I mean, if it turns out that the people don't even believe your instructions or the machine doesn't work, I'm getting past the pure bugs phase, and I'm saying, now I'm going to do a pilot study for what purpose? To decide if and how I do the big one. And the first purpose there is to decide whether an effect exists. And people will tell you that very frankly. They'll say, I have the hunch that Frisbee's test, the Minnesota tennis ball in a bushel basket projective test, would be good for schizophrenia, and I'm going to see whether it is. But I don't want to spend 3 years of my life on this, so I'm going to spend 6 months and only going to give it to a few patients and a few controls, and if not, to heck with it. Does an effect exist is the first question. Secondly, if it looks from your pilot study as though an effect exists, you then proceed to choose a sample size that will suffice to squeak past the alpha that you want, following Cohen's advice. Now, the way you do that second one will depend a little bit on the state of the theory. You might mainly be asking, what size effect do I care about, even? Or you might be saying, I'll take any effect I can get, but what size of effect do I expect to get from estimating from my pilot study? Taking the mean delta equals mu1 minus mu2 as being estimated by x bar 1 minus x bar 2, an unbiased estimator. Even with a very small sample, the best bet between the means is the one that you got. So the question of the assignment of the size of the difference can be a mixture of what you think as a theoretician would be a big enough one to be worth studying the theory in this manner, and the observed mean difference that you got in the pilot study. What do you do after you've plugged in a mean difference there? Well, you write, if you're taking Cohen seriously, you write t equals whatever t it takes in the t table to give you 0.5. Plug in the mean difference that you got in your pilot study and the estimate of the sigmas that you got from your study, and solve for n, right? That's how you use a pilot study in designing your major study. Decide how many subjects you need. Nothing sinful about that, perfectly rational. If I care about a difference of a half a sigma or better, and if in my pilot study it looks like around 0.6 of a sigma, which would be okay, and I want to get alpha 0.1 level of significance, I want to really convince myself and others I won't settle for merely 0.5, then I put those numbers in the t-test and solve for the number of degrees of freedom.
But don't you also want to plug in what power you're after?
Yes. Yes. So, we are deciding how many subjects we run because we want to have 80% confidence that we will squeak past 0.1 if the mean is about this size, and that's one that's big enough for our malicious purposes in testing the theory, and the sigmas are about this size. It's ballpark estimates. If you don't like to take those means, of course, if you want to be more compulsive, then you would, instead of taking the means, you would set up a confidence belt on the sigmas and take lower bounds, or upper bounds in the sigmas and lower bounds in the delta, and plug those values in. You can do it either way. You can do it either as an expected value, or you can do it as a, quote, super safe value. All of which is perfectly sensible. However, notice what it does to the research literature. It means that all of the pilot studies, which are, after all, experiments, they are studies. A certain sample was drawn in this universe, and it had a certain difference of the means, and Omniscient Jones knows what that difference does, and you know, but the psychological community doesn't find out, because if no effect is found, that's the first step. You decide that Minnesota projective tennis ball bushel basket test is no damn good for schizophrenia. I'm going to use the Rorschach instead. No effect exists, so I don't pursue this. But I did a study of the tennis ball projective test, and there wasn't a difference between the schizzes and the controls. And Omniscient Jones knows that, and you and your research assistant know that, but the readers of the literature don't know that. So that means there's a filtering out of something that constitutes an adverse study. Nobody is a crook here. Nobody is being dishonorable. But there is a filtering out by the first purpose of a pilot study. Does an effect exist? Is a filtering out of an experiment that speaks against the test. Now, on the second one, the use of the pilot study to choose your degrees of freedom, what does that do? Suppose you're in a domain in which the crud factor is rather weak, and suppose your theory is totally false. O.J. knows that, but you don't. You got a rather weak size of difference, but it was there in the direction you expected, and you kind of like this particular design. It's sort of clever, and you say, well, I thought I was going to get by with 50 undergraduate guinea pigs, but I'm going to need 100, having plugged in my values in the T or the F or whatever. So you get 100. Now conceive of how that works over a given research domain. We have an area in which the crud factor is rather poor, and then we have another thing in which it's better. In the cases in which it's rather poor, the investigator, if her heart is set on this particular thing, is going to up the degrees of freedom to squeak past the alpha. perfectly sensible thing to do. So there's now a selection in terms of the DF over domains that will be correlated with the crud factor size. Nobody knows how much, but unless you're doing this for some reason after all, and if you get an effect of the right general size that interests you, if stage 2 here, or purpose number 2, is to see to it that you'll squeak through alpha, then it would be irrational not to do it. So you up the degrees of freedom, following Cohen. Perfectly legit, except that this is now an epistemological sieve. That is to say, the experiments that get through the sieve are fixed so that their ends are up so that if the crud factor component wouldn't be quite enough with an N of 50, people will tend to get an N of 100. And that has a further cancerous effect on the literature in that everyone knows that it's easier to up degrees of freedom with some devices than with others. Much easier. So that when my colleague Snyder and his student Gangestad were trying out one of my taxometric methods on Snyder's concept of the self-monitoring person, which everybody, I think Snyder himself had assumed was just a dimension, but got interested in whether it could actually be a type or a taxon, and to play that kind of games with the rather small number of items they had to play with, even with my super methods, they had to have a huge N, so they got a huge N. And as I recall, that paper has an N of not 1,000? It's a big N. Well, now, suppose instead they were studying some other subject using a tachistoscope. You are not going to run 1,000 sophomores in an hour-long tachistoscope thing. That's a different situation from giving them a 20-item paper and pencil test. So that means, you can't tell exactly what it means, but what it means qualitatively is that there are going to be sizable differences in the epistemic sieve here of different theories, because some theories lend themselves to testing by certain kinds of instrumentation and others don't. And so if we, any situation where we're working with paper and pencil questionnaires, we are going to be able, as a result of our pilot study, to boost the degrees of freedom to just about anything that's required. We are not going to do that unless we have a $1 million Bethesda grant if we're using a tachistoscope. So we have, again, without any element of intellectual dishonesty, no skullduggery going on, and people applying the principles of statistics in a rational manner and following Cohen's advice, we have a sifting process as to what surfaces in the scientific literature over research domains as a result of pilot studies. That does not lead me to say, well, shame on us, we should stop doing pilot studies. I am not saying that. I am pointing out that we have here two bad things, and we're caught in the middle. And it is inherent in our situation that we're in that situation. If you decided that I'm going to, before the fact, say I'm only going to use 50 subjects in each group by God come hell or high water, ignoring Cohen's advice, then what would you be doing? You would be falsifying all sorts of peachy keen theories that omniscient Jones knows have high verisimilitude because you are working in a domain in which it's hard to squeak past alpha with that number of cases. Someday, some smart statistician is going to have to sit down and tell us how to fix that up. That is, by fix up, I don't mean you can escape the Tonstoffel principle, but some kind of useful suggestions. Well, if we knew about the size of the crud factor in domains, that would already be a little help, wouldn't it? When we are already quite careful, are we not? At least most people trained at Minnesota are, about methods covariance. We all know that if you're studying the whole thing by correlating different kinds of yes-no verbal questionnaire things, you have to worry a lot about K factor and other things about people's acquiescence, as they call it in political science, and the like. All right, so much for pilot studies. Terrible, terrible problem. Two dangers, and the procedures that help us to avoid one of these dangers tend to lead us more into the other danger. Obfuscator number 8. Selective bias in submitting reports, refuting H null. I guess I don't have to say much more about that. Self-explanatory. We do not know exactly how big it is. It's not zero.
Isn't it kind of like the first one in the number 7? If you don't find anything, you don't send it in.
If you don't find in number, well, it's the second phase. In number 7, you don't even do the main experiment if the pilot study doesn't come out. So what we now have is adding insult to injury. We have first screened it with the pilot study. Then we did the big study. If we didn't squeak through, we don't send it in. I don't think there's any reason to talk any more about that. What more can you say? Everybody that I've asked on the faculty agrees that they have a tendency to not send it in, and then we proceed to explain why that's statistically rational. I think I mentioned that when I cleaned out my files when we moved into this building, I found a bunch of rat studies and a bunch of patient studies that I had never published. And in the case of the patient studies, it was because, although significant statistically, there was too much overlap, and I had learned my lesson from Patterson and Hathaway. In the case of rat studies, it was because they were right on the edge. 07, what do you do with 07? Number 9, selective bias by referee and editor. I guess I don't need to say any more about that one. Number 10, detached validation claim for psychometric devices. I mean by detached, you know, in logic, those of you who took logic heard about the rule of detachment. If A implies B, and then I write down A, then I can write down B, and then I don't have to keep reproving B in the rest of my paper, so to speak. That is, you can detach the conclusion of a syllogism and use it in what follows. Otherwise, all papers would be interminable. Now, the point is that while the rule of detachment is all right in deductive inference, it is not, in general, quite safe when we're dealing with inductive problems. And the reason for that is that in inductive inference, there's a certain probability that attaches to the conclusion, and the size of that probability, or the size of a statement of relationship, bears on what you can do with it in the rest of the article. So you can't just detach the validation claim. But that is commonly done, very commonly done. I would say it's done more often than not. I haven't done a count of this, but that's my anecdotal impression. In soft psychology, it is more common to detach validation claims than not. What the author does is to say, I had a problem here with what I would use to measure introversion, and I reviewed the literature on introversion tests, and I found that the correlations tended to go from so-and-so to so-and-so, and I found a consensus among the experts, and I don't see any reason to disagree with them, that the MMPI-SI scale is the best validated of the batch. It's been studied more on more different samples and different cultures, and the median value of the correlation with criteria like fraternity brothers ratings on social introversion is bigger than it is for FISB's introversion questionnaire. and it has a higher Cronbach alpha, so I consider that this is a valid test of introversion, so I'm going to use it. A valid test for introversion is the conclusion. And in the rest of the paper, you will be lucky if you find very much reference to the size of that median validity coefficient. That's what I mean by detached validation claim. You make a qualitative remark. It has been satisfactorily validated. You make a qualitative remark after reviewing the numbers, and then you tend not to make any further discussion of the numbers. Now, the reason that can give us trouble suppose that the reliability of the SI scale were 80, not a bad value for the multiphasic keys. SI may be a little bit higher than that, I don't remember. Suppose it were 80, then 64% of the variance is reliable variance. And suppose that the validity, some estimate of the validity were 0.40. I don't want to hassle now whether this is construct or concurrent or predictive validity. Take your pick. 40. I mean, for theoretical purposes, we would want it to be construct validity. But anyway, that means that about 16% of the variance is valid variance. Well, now, if we take the proportion of valid variance to the proportion of reliable variance, that's about 1/4 of the reliable variance is valid variance. That is, 3/4 of the reliable variance is invalid. 3/4 of the dispersion of these scores is measuring something about the people, but is not measuring the something that it's christened for, which is SI. Those are not goofy values, are they? Those are not unreasonable values. I get that kind of stuff in personality measurement, attitude measurement all the time. Sometimes even in ability measurement. So a validity of 40, a lot of articles begin surveying the literature and say Thisbe's test for shyness seems to be a reasonably valid test as such things go, and it turns out that the correlation is around 40 with criteria. So you got 1/4 of the reliable variance is valid variance. So if this is reliable variance, this is unreliable. Now, I don't want to hassle about this unreliability, to what extent it's departure from internal consistency and to what extent it's, I mean, we got, all of that is in here. This is all error, all right? You start divvying this up, and you've got a chunk of valid variance here, which is 1/4 of the reliable variance. Now, in my experiment, where I'm correlating this thing with the TAT affiliation score, I'm going to draw a conclusion, if I get a significant relationship with the TAT, that this theory is supported, because it said that there would be such and such a relationship between how introverted you are and whether you did this. Well, I here would be extroverted. Now, all I want to point out is that means I'm taking it for granted that this is the component of the reliable variance that is responsible for the relationship that I'm getting, whereas it could also be that these three are the components that are correlating with the TAT. Statistically, that could be quite possible. If you allow yourself the old principle of insufficient reason, which is in bad odor but is being revived again. Always comes back. You can't kill it. The statisticians and the logicians take turns trying to kill it. It always comes back in some way or other. But the old principle of indifference, I got a range here, a Spielraum, and so to speak, what are my chances, just by luck, that the part of the variance that's responsible for the relationship I got in my study fell into one of these three that I don't want, that I'm not interested in, instead of the 1/4 of the Spielraum that I care about, which is the valid component. If you looked upon that, if you looked upon it in that old Spielraum way, I don't want to press this, but you should worry about it. You might say the odds are 3-to-1 against. I mean, I've got 4 equal blocks here of reliable variance, and what I'm interested in from the standpoint of my theory is only one of those blocks, and the other 3 occupy 3 times as much on the psychometric continuum, so that I may be getting a pseudo-validation of the theory with reliable variance that's measuring something other than social introversion.
Yeah, couldn't you alleviate this problem somewhat by using multiple indicators in a structural model?
Right. That's one of the ways, that's the main way that you want to do it. If people routinely had strong enough predictions of loadings, if they, whether they did it by Campbell and Fisk or by confirmatory factor analysis or by a confirmatory type of path analysis, as long as you play that kind of game, then you're going to reduce this danger. Very few people do, as you know. But if you did that, you'd reduce this danger. But if you just go in and say, well, my theory says introversion should go with an affiliative thing, and I know that I have a reasonably valid measure of introversion, and it's also reliable. You see, you like it to be reliable. We don't like to use unreliable devices, but that means that there's only a chunk, and it's less than half because of the way statistics works. Here it's only 1/4 of the Spielraum, and if you think about the way the mind works, it isn't far-fetched to think that correlations could arise that had a meaning, a component of the crud factor, which is in Omniscient Jones's mind, part of the true theory of the mind, but not in our theory of the mind, that would be giving rise to that correlation. And you will be assuming that because you predicted it, that this is a strong corroborator. All I'm saying is it's a corroborator, but not that a strong one. Okay. Now those 10 obfuscators, as I say, can be divided into roughly into 2 parts. The first, there's some mixing up in here, but in general, the first 5 will have a tendency on the average to make good theories look poor. Whereas numbers 6 through 10 will have a tendency to make poor theories look good. That by reliance on the crud factor and a series of sieves which decide what instruments you use, how many cases you get, whether you send a thing in, whether the editor takes it, things like that, that theories that have very little verisimilitude, the limiting case being a theory that has no verisimilitude at all. It not only doesn't have the causal connections between the conjectured entities proper, the things that it talks about don't even exist. And yet, if we get that out of the right-hand pot and the variables out of the left-hand pot in a domain in which the crud factor is not negligibly small, and then we proceed to sift the whole process of data collection through this series of sieves, we can end up giving a theory a reasonably plausible amount of support. I have not done a statistical study of the literature. I plan to do this. what deters me is the screening out business makes me not know what to conclude about it, but it would be nice to do a statistical study and just see what the box scores are. Not a meta-analysis, but old-fashioned box scores in the soft fields. I'll tell you my anecdotal impression. In the soft fields, the box score tends to be like between 2/3 and 4/5, meaning come out right. Come out right. Maybe 2 out of 3 experiments come out favorably to Jones's theory, and if he's lucky, it's 4 out of 5. You tell me any theory in soft psychology that gets a batting average of 9/10, and I'll leap for joy. It just doesn't tend to happen. And that's the stuff that surfaces that doesn't get up to 0.9. Another interesting way of doing it, which I won't take time at, but is to just say, well, forget about power, and I'm just going to ask if the whole thing is flipping pennies, I will enter a table of the binomial coefficients and figure if I'm just guessing, yes, no, yes, no, yes, no, which side is up, over and over again. Each experiment is flipping one coin. What's the distribution of box scores going to be looking like in that case? And that's a salutary thing to do, and gives you a certain proper skepticism or cynicism about the enterprise. Well, this don't know whether I should talk about that diagram or... Let's talk about the diagram before I go on. And now I'm going to try to go on and say something optimistic. I'm going to try to stop the flow of blood here. But I don't think I need to spend very much time on the diagrams here. They're all blown up. They're very exaggerated, of course, to make the point. These are different cases that can arise. We start out with a certain Spielraum, a limit of crude prior possibilities for values absent any theory. That's generally based upon some previous knowledge, however crude. And what I've done is simply consider various cases here. In the first case, you have 2 competing theories, T1 and T2, and they are both strong enough so that they can set some limits on the values of whatever you're getting. These can be means or correlation coefficients or sigmas or beta weights, I don't care. But these 2 theories are strong enough theories that they tell you what tolerance the theory will put up with for the facts, on top of which then we pile our usual significance test or confidence belt tolerance, so that the theory itself has a certain intrinsic tolerance, and then you throw the statistical tolerance on top of that. Well, now, if the theories are strong enough and the degrees of freedom sufficient, we can have case 1 where you have theories T1 and T2, and they're separated by a big hole in the continuum there. And that means that it would be possible to get a finding that would falsify both of them, say right in the middle. It's incompatible with T1 and it's incompatible with T2. And so the theory is refuted. On the other hand, if you had a finding that fell into the distribution I've got for T1, you're in great shape. That's Popper's ideal case. The experiment has the characteristic that it's capable of corroborating one theory and refuting the other. And if those distributions are narrow enough so that the prediction is risky enough, then you get a strong corroboration for T1. Now, if you don't want to think Popperian, think Salmonian. Damn strange coincidence again. If the tolerance is small enough and our experiment falls into this narrow range of T1, then we can say that we have some faith in T1, because if it didn't have any truth to it, it would be a damn strange coincidence it would do that well. Then I have next a case where you have 2 competing theories and a region of emptiness between them, so that a fact which is consistent with one must be inconsistent with the other. But one of the theories is a lot more tolerant than the other one. So in that case, if I there's an asymmetry here between corroboration and falsification. If my facts fall in the tolerated range of T1, since T1 is rather narrow, it is strongly corroborated and T2 is slain. Whereas if my experiment falls in the tolerant range of T2, it slays T1, definitely. But it doesn't corroborate T2 as much. It does corroborate it. But T2 is quite tolerant. T2 occupies over a third, almost a half of the antecedent range, or the Spielraum, and so the fact that it panned out doesn't give us an awful lot of conviction about T2. I realize I'm not being consistent. I talk about getting conviction, which Popper says is a sin, but the heck with that. Take the next one. You got two competing theories. They're both quite tolerant, but they still don't have an overlapping range. And so that means that an experiment which corroborates one will slay the other strongly, but it doesn't corroborate the one except weakly. And here they're symmetrical. A positive result is a weak corroboration of whichever one it's consistent with. It's still a killer as against the other one. Then you have an interesting case where you have competing theories, and one of them tolerates a range which falls entirely within the range that the other one tolerates. So that there's a sub-range that's compatible with both. We are no longer in a situation, as we were in the first three cases, where any fact that corroborates one refutes the other. Now we could have facts that corroborate one and corroborate the other one also. Although, of course, if you had a fact, say, out in the tail of T2, it corroborates T2 and kills T1. You might think this is an uninteresting case, but it's a very interesting case, especially in fields like genetics. One of the reasons that geneticists like to have some kinds of models, say a nice simple Mendelizing model rather than an apologenic model, or say 3 or 4 biggies, is that you have a bigger chance to give a strong falsification of a simple Mendelizing model, say with high penetrance, than you do with an apologenic model. Some people, some geneticists, like the Swedish psychiatrist Dahlén, argue in favor of big gene models just on Popperian grounds. I don't know whether I buy that or not. I would like to, since I'm one of, as I think I mentioned, one of the last remaining major locus guys on schizophrenia. But other people have said that's an illegitimate use of philosophy of science in the field of genetics, and I don't want to argue that. But it's not a trivial case. It's an interesting case. Whether Popper would say you should prefer T1 because it passed a stiffer test is not clear to me. He says you should prefer to start testing T1, but whether after you've tested it he would argue that, let's suppose you have a thing right in the middle there, right in the middle of both of these distributions. Is there some rational ground to prefer T1 because it had a more damn strange coincidence? I don't know the answer to that. Then, of course, we have next T1 strongly tested, only one theory going, not the favorite case for Popperians, and not the usual case in science. Most scientific experiments have at least 2 competing theories around. Not all. Then we have only one theory, weakly tested, big tolerance, occupies half of the Spielraum. And then finally, with the dotted lines and the question mark, we have only one theory feebly, quote, tested by refuting a directional H null. I have drawn that somewhat tendentiously, I'm aware, but I don't really know what is the right way to draw it. You do know how to draw it if you're talking about the region simply as a statistical problem. But when you put the statistics together with the epistemology, you don't know exactly how to draw it. All right. These graphs are worth dwelling on, reflecting on. They make the case, I think, rather strongly. All right, now then, let me try to say something a little more encouraging. I'm not going to fix you. I don't know how to fix it. I must tell you that sometimes a student comes into me with a theory that he's going to test with the MMPI and down in the court system and deal with two kinds of sex offenders or something, and I just get sort of a spread inhibition over my cortex as he talks, and I think, oh God, this isn't work, and yet I don't like to crush young genius. Nicholas Murray Butler, president of Columbia, is supposed to have said every student comes to Columbia with a spark of genius, and it's the duty of the faculty to water it and make it grow. I don't know if he realized that he had mixed his metaphors there. Well, I feel sort of like, I'm pouring water on this spark of genius, and it's maybe I'll say a few clinical statements about this and leave the actual list for next time. It is an interesting thing. The student gets sort of glassy-eyed, and he sees that I'm not rising to the bait and not turned on, bright-eyed and bushy-tailed on, I see. And so when the student perceives this state that he's getting me into, the response is, well, I gather you don't think this is an interesting theory. And I say, well, on the contrary, I think it's very interesting, especially from the Freudian point of view. Well, I thought you'd think, I realize you're sort of a Freudian, the student says, well, but you don't seem to be very happy with my design. And I say, well, no. And, well, don't you think this is an interesting theory? It's not a metaphysical theory. It's not meaningless in the old positivist sense that the student has read some philosophy of science. And I say, no, I think it's full of meaning. I'm not a positivist anyway. I know what the words mean, roughly. Bertie Russell said it right. If I know the grammar of the language and something of the meaning of the words, then, damn it, I know what the sentence means, whether I can test it or not. I accept that. I'm not a positivist. Okay, well, what's the matter then? And I hardly know how to start if they haven't taken this course, because what has happened is this. And I'm not talking about some dummy, see. This is a smart student, but he's been thinking about this. But what has happened is the following. They get, there are two steps in it, maybe three. They get this sort of simplistic operationism in Psych 1-2, that you have to give operational definitions of all the terms. That leads to a verificationism regarding theoretical statements, right? If all of the sentences, it's like the early Wittgenstein, if all of the terms here are operationally defined, and I don't violate the rules of grammar in putting them together in a theoretical statement, then the sentence is, so to speak, operationally specified, meaning verifiable by observations, right? Flows necessarily from these erroneous premises. And then comes the next step, which is, given that I have this verifiable theoretical statement, due to the sad fact of individual differences and sampling error, I have to worry about statistics versus parameters. But the statistician has told me how to do that. This is an interesting theory. And I say, well, on the contrary, I think it's very interesting, especially from the Freudian point of view. Well, I thought you'd think, I realize you're sort of a Freudian, the student says, well, but you don't seem to be very happy with my design. And I say, well, no. And, well, don't you think this is an interesting theory? It's not a metaphysical theory. It's not meaningless in the old positivist sense that the student has read some philosophy of science. And I say, no, I think it's full of meaning. I'm not a positivist anyway. I know what the words mean, roughly. Bertie Russell said it right. If I know the grammar of the language and something of the meaning of the words, then, damn it, I know what the sentence means, whether I can test it or not. I accept that. I'm not a positivist. Okay, well, what's the matter then? And I hardly know how to start if they haven't taken this course, because what has happened is this. And I'm not talking about some dummy, see. This is a smart student, but he's been thinking about this. But what has happened is the following. they get, there are 2 steps in it, maybe 3. They get this sort of simplistic operationism in Psych 1-2, that you have to give operational definitions of all the terms. That leads to a verificationism regarding theoretical statements, right? I mean, if all of the sentences, it's like the early Wittgenstein, if all of the terms here are operationally defined, and I don't violate the rules of grammar in putting them together in a theoretical statement, then the sentence is, so to speak, operationally specified, meaning verifiable by observations, right? Flows necessarily from these erroneous premises. And then comes the next step, which is, given that I have this verifiable theoretical statement, due to the sad fact of individual differences and sampling error, I have to worry about statistics versus parameters. But the statistician has told me how to do that. You do that with a t-test or an f-test or whatever. So it seems to flow. See, I got the operational meaning of the terms, leading to verifiability of the theoretical statements. And then there is this little problem about sampling, and so I'm going to do a significance test. That's what they're for. See? And he doesn't have that diagram in front of him that I passed out with the 3 boxes. He doesn't even realize that the tough passage is from the middle box to the left-hand box there. That is, from the parameter to the theory, rather than from the statistic to the parameter. And what the situation is that the poor social scientist here has this mess of drawing inferences in a complicated situation with all sorts of sources of error, and the statistician comes to him and says, I will save you from this state that you're in. I will teach you about Fisher and Company. And so he has this truth-grinding machine which deals with only half of the diagram, see? And he takes the statistics course, and they never even mention the other half of the diagram. They keep referring to the hypothesis, the state of nature, right? That's what the books say. That's what the professor says in class. So he learns about T and F and degrees of freedom and chi-square. And you're in. You were told how to solve the problem of induction by means of T-tables and F-tables. But that you only solved half of the problem. You solved the problem about the slippage between the statistic and the parameter, between getting from the observation vector to some postulated pi or omega that characterizes the state of nature. And nobody told you anything in the statistics course about the second step in that, which is to go from this value of delta or Pearson R or whatever to the substantive causal theory that you have your eye on. And so when the student is spinning out this thing, he's got this theory about, I'm not making this up, but this is some years ago. You would know who this is. This was a student who was interested in 2 different kinds of sex offenders. I don't remember, the pedophiles versus the grown-up ones or whatever. And he had a bunch of multiphasics because they always take the mult if they get into that kind of crime. And there are all these multiphasics down at Hennepin County District Court. The student is taking his internship there, and he's got this big N, and he's got these sex offenders. And he spins out a theory about PT and PD and MA and whether you had a battle axe mother and it's the theory is plausible enough. I'm not spitting on the theory, you know, and the more psychodynamic it is, the more I'm likely to like it. And I'm listening to this, but now he comes from that to these damn t-tests, and I realized he's not going to know when he gets done. He's going to have, I can just see it, the final oral. See, we got a significant T between the pedophiles and the non-pedophiles on SC. We thought we'd get one on PT, but we didn't. And on PD, there's a trend, but it's in the other direction, but not significant, and so on. And the faculty's sitting there, and they're spinning out ad hocery on this damn mess of nothing. And it's just so depressing. I mean, it's just so depressing. It's a fraud. It's what Feynman in his autobiography called cargo cult science. You ought to read that autobiography. Cargo cult science. That is, it's got the earmarks of science because it's done with numbers. We all know that science is done with numbers, and you can look up this in the t-test. But it's just the connection between this pitiful set of marginal trends and this substantive theory that he's so interested in is so tenuous, and the chances that the dissertation ends up with, say, having made 7 quick predictions, and what you might like is to say, I'm going to take all 10 of the clinical scales and I'm going to rank order them. I'm going to say the big difference is going to be on SC, and the second is on PD, and MF is going to be in the opposite direction. I'm going to order those 9. That's what Freud's theory of homosexuality amounts to, or whatever, see? Well, if he did that, you'd get pretty excited, wouldn't you? It's like Meehl's theory of the weather. It'll rain on 5 days. But they never do that. You can't blame them. You can't do that, is the point. You can't go from some psychodynamic theory of pedophilia to the multiphasic profile and make a sufficiently damn strange coincidence set of predictions to have a powerful something when you get done. It's just not the nature of the subject matter. We're not in that stage, even though the mult is a good test. It's just not capable of answering that type of question. So that when you write down the Lakatos equation and you start looking at the various auxiliaries, including the psychometric auxiliaries, look at all the gunk that goes into an MMPI scale. It's not valid variance, for Pete's sake. And the fact that the alphas are low because that's the way it was built. They didn't give a darn about that except on scale 7. And how do I know, is it the subtle or the obvious items on HY that are doing it? Well, at least that he could analyze, see. If you start breaking the items down into scales into small enough sets of items, then you begin having problems with how few items you have tapping a certain thing. So I get this big pall of cognitive depression coming down over me. And as I say, unless the student has taken this course, he doesn't see what's the matter with Meehl. I mean, I'm interested in the theory, and I believe in the MMPI, and I like to talk about Freud, and there I am, looking all down in the mouth. And, well, that's the way it goes. If you take those 10 obfuscators together and you take a typical study using some psychometric device that attempts to test a really interesting substantive theory of the mind, it is usually in very, very poor shape. Very, very poor shape. And so now I will try next time. As I say, I can't completely cure you, and because it wouldn't be curing you or me, it's curing the fact that we went into a crazy field like this instead of being geneticists or chemists or something. But I will say some positive, constructive things. I really will say some good things.